Good morning. Thank you all for being here. I appreciate it. I hope you all had a fantastic time at the party last night. City Museum, super awesome. St. Louis, cool city. I'm very excited to be here talking to y'all about using data-driven metrics to anticipate and prevent security incidents. So this is one of, I believe, the few security talks here at Strange Loop. Very excited to be doing this. Let me introduce myself. So my name is Caitlin Buckshaw. I'm a product security engineer at GitHub. I've been working there for a little over 2 years on or adjacent to the PSIRT team. And before we get into the meat of the talk, I really want to tell you a little story about how I got here on the PSIRT team, because it really sets the stage of the purpose of my talk today and my mission going forward. So my background is actually in corporate security, where I did a lot of threat hunting and then moved into consulting for an EDR vendor. While I was working with this EDR vendor, I got to see IR, or incident response, from the customer perspective, or the vendor perspective as well. And I found this really fascinating because I was working with customers who had just come off of data breaches and were looking for software to implement to prevent this from happening again. And it was so fun for me to hear their stories and learn what happened, but it was also incredibly heartbreaking because these folks had just come off of some really difficult work and they just needed people to vent to as well. And so I was consulting with them and installing this EDR solution, but also I was an ear for them. And while doing this work, I got very interested in incident response and why this area seems so underfunded, under-resourced, and definitely unprepared for a lot of these scenarios that could have been prevented. So I went on a little mission myself and decided I wanted to do this work. So I went looking for a position, found one with GitHub, got hired. The only problem, though, is that this was product security. And product security, also known as application security, web security, was a totally new world to me. I was familiar with OWASP and bug classes, but never actually worked in it. I came from threat actors and ransomware and really funky PowerShell scripts that we would just block entirely. And so this was totally new. So I knew that I had to do it the hard way, because that's just how I learn, throw myself in the deep end. And in order to do that, I had to take on my first incident. So a few weeks after I onboarded, got to know the lay of the land, learned the product, met a bunch of engineers, and learned the incident response process at GitHub. I told my manager, next incident, I would like to be the incident commander. So she said, okay. So a few days later, me nervously waiting for my first incident in product security to come in, I am excited, of course, because who knows what's going to happen or what's going to come in. We have a lot of product features at GitHub. You never know. So I am waiting, and I get a knock in Slack a few days later from my manager, and she says, hey, we just received a bug bounty report, and it's going to need the full incident response investigation. So I say, okay, let's go. I'm ready. So naive. So I log into our HackerOne portal for one of the first times since I was so new. And if you're not familiar, HackerOne is where we maintain our bug bounty program. And we have a fantastic bug bounty program. Shout out to them. We just celebrated 9 years of the program. We have a great blog post posted. Fantastic people, both internally on the program and externally. We have fantastic researchers all over the world hacking on our product. So it's awesome program that we have. So I log into it, very new, very green to this, and start reading this report. So I'm reading the title, and the first thing that jumps out to me are 3 little letters. And if you know what I'm talking about, you know what 3 little letters I might be referring to. And then I continue reading, and I see 3 big letters, RCE. If you're not familiar, remote code execution. So I start thinking, oh no, what have I done? What have I got myself into? My heart starts beating, I start sweating a little bit, but I'm also really excited. And this is where I coined the term chair adrenaline. And I know I'm not smart enough to come up with this term myself. I'm sure it's out there. I'm sure other people have coined it for other reasons. But for me, this was sitting in my chair, but I felt the adrenaline just coursing through my veins. And I'm not an adrenaline junkie either. This is not something I go out looking for. But when it's at my chair and I'm in the safety of my home, it was kind of exciting. So long story short, this first incident of mine ended up being 7 CVEs, which was a combination of both bypasses discovered by the researcher and internal findings from our amazing folks on our team, and a very lengthy blog post that you can go read on our website still today if you want to read about my very first incident. And I obviously can't take all the credit for this. There were amazing people that helped me along the way, engineers who were working with the code at the time, security folks, our wonderful security lab folks, other incident responders. So it was a very collaborative effort. But this first experience got me so excited and fired up. I get excited just thinking about it right now again. But the reality is that it's not good for business, and it's not good for customers, and it's really not good for our hearts and our health either. So I decided to take it a little bit upon myself and go on a little mission, and that's going to be the root of this talk. So what if I told you that incidents can be prevented? I know, it's shocking, right? So a little bit of talk on our incident response process at GitHub. And I know this is a, strangely, this is a developer-focused conference, and this is a security talk, so just bear with me for a moment. You may be familiar with PSIRT. PSIRT is more corporate security. They handle things like threat actors and ransomware, more of what I was used to. And you may be familiar with them from the hacks in the news right now around MGM. My heart goes out to all those folks involved with that. That's a nightmare. So that's PSIRT, and that's not what I'm doing, and that's not the purpose of this talk. What we talk about, or what we do, is product security, so bugs in code. So hopefully a little bit more relevant to y'all. In many companies, they will have established team to handle the IR process, just as we do at GitHub. So the way it works is we receive a report, similar to how I told in my story, and in that story it was from our bug bounty researchers. We get a large number of our reports from our fantastic researchers, but we also get a large number of reports internally from our fantastic hubbers who are also security-minded and know where to report these findings to us in our CERT channels or emails or wherever they can find us. And sometimes we get them from customers or social media. Those don't usually work out too well. So the very first thing we want to do when we receive a report is validate the report. And that's going to involve things like triage and reproduction. It's incredibly important to us that we are going to be able to reproduce this bug and make sure that it is a valid security concern. And the reason for that is we understand that for engineers, security incidents are not your day job. We totally get that you have your own OKRs and KPIs and product features to push out and better our product. So we are effectively taking you away from that. We want to minimize your time in our security incidents, and one way we do that is validating the bug and making sure that we are bringing you in at the right time for the right reasons. Once we do validate the bug, we are then going to present it to the owning engineering team, who are the experts of that area of the code base. They will work on the mitigation. So that is not anything that PSIRT will do. The engineers will work on mitigation, and while that's happening, PSIRT will then work on the investigation side and the response side. So the investigation is going to include things like scoping for impact, looking for exploitation, and developing a story that we will then use to present to our stakeholders and develop a notification strategy. Sometimes that looks like a direct email, sometimes it's a blog post, sometimes it's a change log. It really just depends on the specific incident at the time. Once it's all fixed, once the notification is out, then we will work with engineering to develop a root cause assessment. It's incredibly important that we get that captured, and then we're going to take that, put it in a postmortem, along with our timeline and our full investigation. We're going to merge that into a repo, and it's going to stay there effectively forever for historical context, things like audits, which are very important. And then we can always reference them if we have other incidents in the product area or ever need to go back and look at previous incidents. In the past, this is where it ended. When an incident was concluded and a postmortem was published, then that's where we stopped. So now we have created a new team called PSIRT Engineering, and now we hand the incident over after the postmortem is merged to the PSIRT Engineering team, and that's where we're going to do additional work to understand how and why it happened in the first place and how we can prevent it from happening again. And that's what we're going to be talking about today. So let's talk about PSIRT Engineering. What is it? Why did we do this? So while we were working incidents, and when we were closing them out, we realized that we had a gap because we were working the incidents, we were fixing them, we were notifying our customers, we were doing the job of incident response, but we were missing a huge piece in where we could prevent future bugs and incidents. So we needed to fill this gap with this new team. And in order to do that, we established some goals, and our primary goal was to capture all of the data we possibly could on all of these incidents, because every incident, I'm going to say this a lot, is an opportunity. It's an opportunity if we grasp it and capture all of the information of every single incident, and then we can put that into our scripts and our graphs and our charts and analyze it. And so the reason why this team was created as a byproduct of PSIRT and after the incidents is because oftentimes incident commanders, those in charge of the incidents, just don't have time for this. They jump from incident to incident, which a lot of people don't realize, is that when one incident ends, they are often going right into the next investigation. So there's not enough time for them to be able to do a deep analysis, a deep dive, look into preventions, look into the data. So we saw this opportunity, and we knew we had to do something. Because ultimately, what we want to do is we want to shift left. We want to catch the bugs earlier in the design phase, not in production. And so there's a lot of work that we can do here with the information these incidents provide. So what does that look like? Well, we had to establish some objectives, right? We had to define what we were really going to do here. So number one was trends. Of course, I've mentioned the data, right? We want to capture and analyze this data, understand the areas of opportunities across the entire product. With the data that we capture, we can identify the trends, understand what we missed, and what we need to do to prioritize time in order to focus on these specific trends and pain points, as we start to call them. The next step is to share. So cross-team collaboration is an incredibly important part of this process that oftentimes gets missed. We capture the data, but we want to make sure that data gets used and shared with the right folks. And so we're going to talk about how we ended up doing that here. It's important for us to maximize that data and increase any of the outcomes of our findings. And then the third stage here, third objective, is going to be variance. And that is going to be a little bit more of the technical side, where we get to be engineers or researchers and really dig into our product. Because every incident or finding is a huge opportunity. It's a signal in our code base with a lot of noise that we need to dig into more of this area. And so variants should not be ignored, and they need dedicated time to dig into because it is a time-consuming process. But I will tell you that one of the worst feelings is when you're working an incident, you're getting close to closure, and then a researcher, usually externally, will present a new report that's either a bypass of your mitigation, saying your mitigation was not robust enough and you need to go back to the drawing board, or they found an additional variant in the area that you could have found internally, but you just didn't have the time and resources to do that. So there's a huge opportunity here to reduce that and prevent that very demoralizing feeling of a bypass in the midst of an incident. So let's dig into each of these objectives, and I'm going to explain how we approached each of these areas with this new team. So trend analysis. This is very important, right? Because we have limited time, we have limited resources, we need to prioritize and understand based on this data that's being presented to us directly from incident response. And in order to do that, we have to analyze the data and develop these trends. So this is a huge goal here. It helps reduce business risk, of course, but it's also going to do things like cut down on costs, and not just monetarily, but also engineering time. You'll have to spend less time in security incidents, bug bounty payouts. You know, we hope that that'll reduce bug bounty payouts. And of course, reputation too. Reputation is a cost that we consider, especially in PSIRT. I don't know anybody on a PSIRT team that doesn't take great pride in the company that they work for. It's a huge part of being part of a PSIRT team. And maintaining things like trust and transparency with your customers is part of our overall mission. And so maintaining that reputation is a huge part of this as well. So how do we capture the data? So we capture it in a variety of ways. And since we heavily dog food the product, heavily dog food GitHub overall, which is a topic that a lot of Hubbers have presented on before, we do rely on issues and labels and a lot of automation to track every single report that hits our door so that we can capture all of the data from it. So we do this by utilizing automation through Slack bots and our API. We're going to answer a series of questions that our Slack bot is going to ask us. It's going to capture that information. It's going to put it in an issue, and we're going to be able to see all of our incidents here in our repo. This is, of course, going to then make it onto our databases where we run scripts and create dashboards, which we can then mess with to determine our trends and do more trend analysis. So one of the ways we do this is to create a sort of a calculator. So once we have the data, we need to do the trend analysis. We need to identify the patterns so that we can then shift left and find the bugs earlier in the design phase. So we plug our data through this calculator, and this is something I've been developing internally. It's specific to GitHub and our concerns, but it's very similar to a CVSS calculator, if you're familiar with that, which is the Common Vulnerability Scoring System, and that's used to determine vulnerability severity. However, this is internal to us. So we want to look at each of these areas and put a multiplier on it to develop this scoring system. So we look at things like product area. Has a specific product area received multiple bug reports? If so, that'll get a multiplier. Severity, so low, medium, high, critical. The higher the severity, the higher the multiplier. Notification, was a notification sent out? Since this impacts the reputation, that'll get a multiplier. Preventions, were preventions bypassed, or are we missing preventions and additional time needs to be put into developing them? If so, that'll get a multiplier so it gets more eyes on it. Bug class, different bug classes have a different weight to them, so that'll get a multiplier. And then the last one is variance. So have variants been found through variant analysis? That'll get a multiplier as well. And this is something, as I said, I'm developing in GitHub, and I hope that one day will be a future talk on how we use this internally. So hopefully we can look forward to that in the future. Now, what does this look like visually? So by using Python and pandas, of course, we can develop some charts and graphs that give a more visual analysis of our trends. And this is great for things like LT, of course, who want just a very fast look at what we are dealing with in PSIRT, and from our incident response teams who work with our bug bounty folks. And so this is really helpful for sending it up the chain. So this is how we capture our data and what we do with it and how we're analyzing it internally. But then the next question is, what are we doing with all this data? So that's what brings us to how we share it and cross-team collaboration, what happens to be one of my favorite parts because it's allowed me to get to work with so many fantastic engineers and different teams across our whole org. So there's a lot of value there that I found there. Our goal was to break down silos and disseminate this information that we were seeing from incidents to communicate to the right responsible stakeholders at the right time and help them be accountable. Now, a funny thing is I actually have been reading a book recently called Fancy Bear Goes Fishing. It just came out a couple months ago. And in the beginning of the book, the author talks about how the early days of the internet, the folks who were working at companies were experiencing security bugs, and they were playing more like whack-a-mole, right? Where they were each individually fixing the security bugs that were found in their systems, but not really sharing the information. So thankfully, in 1999, CVE was established by MITRE, and that created a central location to share this information. Now that's externally, but what about internally? Are we sharing this information with the right folks? And that's what we identified as a gap here. So we wanted to get this information to the right people, but we also want to be as efficient as possible because we all know that Zoom fatigue is a thing. We don't want to add more meetings. And so we want to make sure we're capturing the info, but getting it out to the right folks smartly and efficiently. And the cool thing about this process, and one of the reasons why I say it's part of my favorite process of building this team, is that collaborating with so many folks on different teams allows us to see a different perspective from each of these engineers. Sometimes we get historical context from folks that have been with the company for over 10 years, and they can offer something so different than somebody who maybe is new and came from a different company, maybe like AWS, who then has a different perspective. And bringing those folks in the same room can have major benefits if we utilize it correctly. So what do these teams look like? Well, we start off with our PSIRT team. Of course, they're there. Then we have our bug bounty team. Our bug bounty team are often the folks most familiar with our entire platform and the product overall because they see the bugs that are hitting our systems day after day. They know every single product area and they know the bugs that are concerned there. So they are part of this process. Then we have our PSE team, which is our product security engineer team. And they are comprised of a variety of smaller teams with different skill sets. So we're going to bring them in as well. And then also we have our security champions. So our security champions are a recent addition to this process. And those folks are engineers who are more security minded. So we bring them into security events quite often. The cool thing about bringing all these teams together is that not only are we encouraging accountability, which is incredibly important during this process, but we're also practicing kindness, which is an incredibly important thing that we do in PSIRT. It's very important that we always run a blameless investigation. There's no pointing fingers. There's no blaming anyone. We look at a bug as an opportunity for the product overall. How can we improve this? And so from start to finish, it's blameless the entire way. And it's very important that we maintain that and we make sure that folks are aware of that as well. We want to have open communication in a comfortable setting and let the thoughts flow, the ideas come out, much brainstorming as possible. So that's the most important thing here. So how are we doing these meetings or sharing this info? Not all meetings, trust me. So each phase of sharing our findings is going to be a little different. So we have a bi-weekly discussion post. Once again, dog fooding our product, we use discussions, and we're going to post our findings in these discussion posts every other week. This includes things like trends that we're seeing, pain points that we're seeing, and any of our closed postmortems that PSIRT has closed out for the past few weeks. Then we take this discussion, and that's going to be the agenda for a meeting that is also bi-weekly, but it's not too long. It's only about 30, 40 minutes. And we're going to look at this agenda with the teams that I mentioned, and that's where the free-flowing discussion starts to happen. It's comfortable. We have brilliant people in there. They just jump in when we get to a specific incident, add their ideas, discussions. We look at preventions. We dig into code QL queries. How did we miss this? How can we prevent this? And this meeting has been so beneficial for bringing the teams together and sharing ideas across the team. So, as I said, one of my favorite things, and I'm not even a fan of meetings. Then we take that info and our findings and we post them in quarterly discussion posts. So these quarterly discussion posts are going to have our main pain points from trends that we're seeing in different product areas, and we share those to everyone. They're accessible to everyone. And of course, we're going to share them up the chain to LT, who are always curious as well. And then we have annual reports, and these are really helpful because we're able to look at it from a high level and see where in our product we have more areas of opportunity, what's better, what's worse, and what still needs work. So that's how we are sharing the info. Now let's get into some of the more technical area by digging into variant analysis. So with variant analysis, this is where we get to be the bug hunters. We get to be the engineers. We get to be the researchers. And we have the data. We've identified the pain points. We know where we need to prioritize and put our time. And so that's where we start to dig into these variants. And I wish I could say we do these on every single one of our incidents, but just due to time and resources, it's just not possible at this time. So we have to make sure that we are focusing our time in the right place. So you may be wondering, what is a variant analysis? Variant analysis is the process of using a known security vulnerability as a seed to find similar problems in code. And what receives a variant analysis? So any bugs that have been identified as a pain point, that's going to look like areas of our product that have received over 2 bugs in a short amount of time. So automatically, we have an action that'll see that, and it'll automatically add a variant analysis label and open up a new issue for a variant analysis, all automated on the back end. High-risk bugs, anything that's a high risk that we really have all hands on, then we are going to absolutely dig into a variant analysis. And any bugs that also bypass preventions. Because if one bug bypassed preventions, we really need to dig into that prevention to figure out how this happened and how we can prevent it. So what does our VAA process look like? Well, thankfully, I'm not the only one doing the variant analysis. We have what we call a working group, and that's comprised of a few members from different teams across our PSE umbrella. And so those folks have different skill sets and different perspectives for doing these variant analysis, and that's very helpful. So we have folks from PSIRT, our bug bounty team, we have folks who specialize in code analysis, and a few other areas that can really help us do things like build our code QL queries for doing this variant analysis. We also have predefined templates where it's very simple. We just fill out a series of questions. It's all streamlined, and we know what we're looking for when we're performing this variant analysis. And then we want to always make sure we are documenting our methodology and the outcomes. So we do a variety of ways, or perform variant analysis in a variety of ways. And we want to make sure we document how we're doing that. And I'm going to talk about that in a minute. And then the last thing here is no variance is still a very important part of the process. And I put that here because when I first started doing this, I was very discouraged because I wasn't finding variance. And I thought, you know, maybe I'm wasting my time or not doing it correctly. But a very important person, very smart person, pointed out to me that no variance is still a finding, and it's still important that we document that, because at that point in time, that product area was functioning as designed, and that is an important piece to remember in case we ever do get a bug in the future. Then we can go back on this and see how we tested it, how do we miss it, or was it implemented, the bug implemented after the fact. So it's a very important piece to document. Now, what does our application security testing look like? So this is how we perform our variant analysis. We do this in a variety of ways. Like I said, we're going back to our researcher roots, and we utilize things like DAS, which is dynamic application security testing, or more manual. So that's when we really dig into burp features, or we walk the application. We really dig into the new mitigation that went out and see if we can break it. We also utilize things like code search, and shout out to Luke, who gave a fantastic presentation yesterday. If you didn't catch it, highly recommend checking it out on YouTube when it gets published. But he's from the Blackbird team who built out the new code search, and I'm a big fan of utilizing this in our product, and so highly recommend using it for testing as well. And then on the other side, we have our static testing. So this is an area that we have well established. Of course, we utilize CodeQL heavily. That's a part of our product through our GAS offering, which is GitHub Advanced Security. So we have CodeQL queries that run for code scanning, and those are already established. So sometimes we will lean on those, but other times we'll develop our own queries to run static analysis against our code base internally. Those are handy when we can define the source and the sink in bugs like data flow bugs like cross-site scripting or injections. We also use Brakeman, of course, because we are a Ruby house. And then we also have custom tools being developed inside by our hubbers. And those are fantastic tools that we use for things like authorization bugs, which sometimes can be tricky. And so it's awesome that we work with such great developers that can build these tools. So most of our variants are going to receive a combination of these tools to develop a variant analysis, document it, and get it into our repo so that we can maintain it and reference it whenever we want. So after a year of building this team, what's come of it? Well, thankfully, we have some good news. So first off, at the top, of course, we've had some internal findings, which is huge. Anytime we can find a bug internally before it either gets found externally by a researcher or before it even goes out the door, that's a huge win for us. So that's top of the chart here. Second, relationships and collaboration. As I've been saying throughout this is a huge opportunity for us to work with very knowledgeable people across the entire org and also get their perspective and do some knowledge sharing. So that's been a huge part of this. Improved preventions. So this is another part that I'm really proud of in that we have, in fact, improved our preventions that have trickled down into our product that also serve our customers. By finding things that maybe have bypassed our CodeQL query that maybe shouldn't have, we have made direct improvements to that. So that's awesome to see. I love that. And then small footprint, big impact. So while I've been talking about building out this team, the truth is that it is a one-person team. I am the team. And means that, we have limited time, limited resources, and that only one person. However, thankfully, I'm able to lean on a lot of people. So while I say that it is a one-person team, I do pull from a whole bunch of teams and get to work with brilliant people that have taught me so much. So in a way, this little team is a mixture of incident response, red team, code analysis, assessment, security reviews, vuln management, data analysis, and developing too. So we have a lot going on here. But of course, that comes with some challenges too. So as I mentioned, it is a team of one, means a little bit of pressure, especially when we have a tricky year across the industry and internally at GitHub. the macroeconomic uncertainties are always looming, especially when you're building an experimental team and trying to show and prove impact at every step of the way. So definitely a concern there. But I feel like the mission is so important, and the fact that we are seeing direct results of this mission in just 1 year of building out this team, I hope that the impact speaks for itself, because as you can tell, I am a big fan of incident response and how we can prevent these from happening, and utilizing as much info as we can from these incidents and not letting an ounce of that data pass us by. So thank you all for being here. I really appreciate it. Very happy to be talking at Strange Loop, and I hope you all enjoy the rest of your Friday.